Good morning. Welcome to unit number 4 of the course Advanced Bar System Protection. In unit number 4, we will discuss about numerical relays. We will start with the basic block diagram of numerical relays, and we see what are the important components and the algorithms which are used in numerical relays. And next, we will move on to applying this numerical relays for protection of transformers and alternators. So in today's class, I will start with an introduction to the numerical relays, and then we will move on to the block diagram. So far we have completed unit number 3, where we were discussing about bus bars and their protection. In this video lecture, after the completion of this video lecture, I hope that you will be able to describe the components of numerical relay along with its block diagram. I hope that you will be able to list the advantages of numerical relays when compared to the other relays. Moving ahead, I will start with the evolution of protective relays, first generation relays to the latest generation relays, and then we will move on to what are the advantages which are offered by the numerical relays when compared to the conventional electromechanical relays. And next we will move on to the development cycle of a new numerical relay. What is the procedure when we move on to development of a new numerical relay? And finally, we will see the block diagram of a numerical relay and the simple function of the important components. Coming to the evolution of protective relays, we have already seen these things. During the 1880s and 1900s, we used to have meters which do have contacts for the protection of electric devices. And then they were replaced with the electromechanical relays, which we call them as the first generation relays. They use it to have moving parts, and they use it to work with the type of magnetic field and moving parts. And then we had this vacuum tube type of structures, which started with the early inception of silicon industry. And then we had this improvement of vacuum tubes, what we call as transistors. So we had this chips where we had this multiple silicon components, multiple semiconductor components implanted in that one, and these were used for protection of electrical equipment. And with the help of this very large scale integrated circuits, this IC chips, the cost of IC chips was coming down, so we were more inclined to transistor based relays, even though they had their own limitations, but we moved on to transistor based relays. And after that, these were called as static relays. The next generation was the development of a microprocessor. And somewhere in 1970s, we had this first microprocessor. And the application of microprocessors, the transistor-based relays used to lack of memory requirements. They didn't have a memory, so they used it to work only with some logics. But then came this microprocessor-based relays, which had this CPU and memory. So all these things were there in the microprocessor. So it's not only just like a do or no do type of thing. You can take the data and you can process or analyze it whatever you want to do. It is just like an artificial human being. So microprocessor-based relays come into picture. We started using microprocessor for protection, and after 1970s. There were so advancements in the microprocessors. Very fast microprocessors are coming to picture. Now we are using computers now with very advanced microprocessors. So all this, whatever we call, whether it is a digital relay or a numerical relay or a computer-based relay or microprocessor-based relay, they all tend to have a microprocessor. It's a common word which we generally use. They use microprocessor, but the generation of microprocessor is varied. Nowadays we do have what we call as quantum computers, right? So they are very, very ultra fast, and they can give us data, whatever data which we want to analyze. We can analyze any situation in that. So this is the evolution of protective relays, from the early meters to electromechanical relays, next to static devices, next to microprocessor based relays, and with advanced microprocessors now. So coming to the generation point of view, see, this was the first type of during 1900s. Before that, we used to have meters. This was the first one, electromechanical relay. They used it to be very bulky. And then with the advent of your semiconductors, so we had this static relays, what we call them as analog relays. We didn't have any digital type of things. We used to have only analog semiconductor devices. Those were termed as second generation relays. And next we had this digital relays, where we do have this digital outputs and everything. Signal was processed in digital things. So we used to call them as digital relays. And after this one, we have this advanced microprocessor. We are using directly computers. We are collecting the data. We are getting it. We are analyzing it. And these next generation or advanced generation relays, they are termed as numerical relays. And this is the, see, this was the first generation, second generation, third generation. Some engineers, they call this as the generation cycle. First generation electromechanical, second generation static relays, third generation was microprocessor, fourth generation is advanced microprocessor, or we call them as numerical relays, and fifth generation now we do have devices, intelligent electronic devices. I've shown you in unit number 1 about this intelligent electronic devices. So from here, these are called as digital relays. So it just goes on changing. What is the change in these generation relays is that the parts which we are employing and the principle of operation is also varying. And next, see, this is the timeline of evolution of the relays. As already I told you in unit number 1, a quick recap. See, up to 1900 to 1970, we used to have this initial type of relays, what we call as electromechanical relays. There were so many types: overcurrent relay, differential relay, directional relay, distance relay, power line carrier communication. So all these things, they came under conventional protection schemes. In 1970, somewhere in 1965 or so, we had the semiconductor chip industry growing very fastly. So during that time, we had these rectifier circuits, transistors, integrated circuits also came into picture. And see the timeline. By 1990s, we had this advanced microprocessors. And with this microprocessor and with the advent of your communication sector also. Earlier we used to have this PLC communication, power line carrier communication. Then came this traveling waves. Next came this adaptive algorithms. Next came artificial intelligence in 1990s, neural networks, fuzzy logic, etc. So with all these communication type improvements and also with this hardware type improvements, now we are moving our protection schemes to very advanced schemes. We started with the transient based protection schemes, and then we had this wide area protection schemes. Next is integrated schemes, and now everything is being stored in, now we don't need any memory right now. Everything is being stored in cloud, big data. So whatever the data which you can get, so much data. Earlier we used to have limitations on memory, and we used to have problems, how to store this data and where to store this data, how to analyze this one. So all this big data, cloud computing, etc., they came into picture somewhere in 2005 and 2006 slowly, and now they are in the boom, right? So now you can have so much amount of data, you can analyze it. So with the advent of advanced technologies, the protection schemes and the protection scenarios have completely changed. Now we do have integrated wide area protection schemes. These are the latest developments which are happening now. And everything is now, whatever the data which you are getting now, it is being printed with GPS systems. You will be having GPS stamps from where you are collecting, so no need to bother about locations also. Whatever the data which you are getting, it is having a GPS stamp. There are so many GPS satellites which are revolving around the earth, providing you accurate location and time. So much data coming in, and there is no bothering about storing the data also with the clouds coming into picture. Now, one more thing which has changed so much in the recent past from your first generation to the latest generation release is the software. Earlier in first generation release and second generation release, we didn't have this concept of first generation, the electromechanical release. Next was static release. So let's say these things as digital release or microprocessor release. Earlier release, they didn't have this concept of software. They used to have very simple mechanisms, just like attracted armature, hinged armature, induction type of things. But in digital, whenever we brought this microprocessor which had this memory concepts, then automatically the software also came into picture. This is a major difference when compared to the previous generation release. Apart from the hardware, there is a concept called as software. What is the advantage of this software? So the concept of software is that you get the data, you are supposed to process the data and analyze it. So the relay is going to analyze in different fashions. Earlier we used to have in electromechanical relays, we used to have only just type of a comparison, yes or no, right? It's just go or no go, that's it. But with the software mechanism which is present in this relays, now we are just having so much data and this processor is trying to analyze. It's not just a yes or no concept. It is analyzing the entire data and giving us a clear picture. Not completely a clear picture, but an advanced picture when compared to the previous things. In all of these numerical relays, the hardware remains the same, more or less. It only changes with the measuring components. The hardware, most of the times, it remains the same. What's the difference in? It's a software. So what operations you want to do with the data which you get? So that is varying. You understand? So the algorithm will be varying, the software will be varying. Hardware, it remains the same. You just need to collect the data. That's it. What type of data? That is one of the major reason. That is the reason. That is one of the important information. How you will be selecting the software, the type of measurements, etc. But whereas analysis of data, that will be done by the software and the algorithm which you choose. So nowadays, the numerical relay manufacturers, they are more concentrating on software, not on hardware, because hardware, it remains the same. Maximum you can do current collection or voltage collection or some other component collection, right? That's it. So once they are collected, it is just data. So now the question is, how much data is there, how you want to process it, how many calculations you want to make on this, that one. That is a concept now. So the algorithm and the software which supports that algorithm is now a big question. So that's why modern day devices are basically now, they are more spending on softwares rather than on hardwares. So that is a major difference. So this is a quick comparison of the numerical relays versus older generation or conventional relays. The conventional non-numerical relays, they were just go no go devices, right? And they use it to have only one performance. They use it to perform only comparison. Whether if it is greater than the pickup value, then give the signal. If it is not greater than, then leave the signal. Next, they use it to have some sort of moving parts. So they just had this concept of torque balance. And next were the numerical relays, the modern generation relays, which use it to perform numerical computations. They can perform multiple functions, and they are actually having an advanced processor where they can perform different operations on these data. The next one is now, with all these advantages and disadvantages gone through of numerical relays and non-numerical relays, now let's see how the development cycle of a new numerical relay is being done. So whenever you are trying to develop a new numerical relay, what you will be thinking of and what is the procedure behind developing a new numerical relay? See, first of all, we must think about what our actual problem is. So first of all, I will find out what the actual probabilities, and then I will try to put some sort of mathematical modeling of that particular relaying problem. So once I do have the idea, let us suppose I want to measure some sort of voltage or some sort of currents, or let us suppose directional relay is one big problem. So now my thought is about to identify the direction of relay. If it is not in according to my expectations, then I should give an alarm, right? So this is my concept now. So this is my problem now. So what I will do, first of all, I will write a mathematical equation. So what I will write a mathematical equation once I is measured. So if it is positive value, if I is greater than 0, then automatically my relay must be okay. It must not operate. If I is less than 0, then the relay must operate. Like this, some sort of things will be developed now. So once I have obtained some sort of mathematical equation, then immediately what I'll write this is my algorithm. I'll write a code like that. So once I write an algorithm or a pseudocode, whatever you call it as, it is just like a plain thing, right? Once I do it, next is development into a computer understandable program, right? So which means I should choose a language now. So some sort of high level language with the algorithm. Though the language selection is your choice. Once I select the language, now I do have a program. Now what I will do, I will just first of all check it. Alright. So I'll test it with simulated data. So where I'll get the data? Once I have mathematically modeled it, so from there itself what I'll get the data and I will test with that. If I find it okay, then I will develop a machine code such that it will be okay with my processor which is available with me. So once a machine code is generated, now I will shift the entire data now, whatever the machine code is generated, that will be transferred to your numerical relay. So now my digital program is ready and now it has been given to numerical relay. So my numerical relay is ready now with all the software, hardware and also software, right? Once it is done, I will test with now test inputs. So I'll be having a relay test bench all the time. So it is just like an artificial fault creator. So with the help of the relay test bench, I will test this relay which is now ready. If it is okay, then no problem. If it is not okay, then again I will try to modify the algorithm. So modification of algorithm is done in two ways. One with the actual data, the other one is the simulation data. In either of these cases, algorithm is to be modified and it is to be improved. Now after the test data, if the analog data is also checked and if it is working. So what I will do, so whatever the relay which is present right now, older generation relay, I will keep it with the in parallel with that one. And I will try to give it with real life inputs, CT and PT. And I will evaluate the performance for over the period of 2 to 3 years. You know that it is a very long time, but we are supposed to do it. If I find it satisfactory, then I will go with a commercial launch. So this is the development cycle of a new numerical relay. Once it all passes these tests, then it will be commercially launched. Understood? So any type of problem which you do have, you can develop. The only thing which is new here is nothing but you must be able to mathematically model it, and then you are supposed to write it with the help of an algorithm. You should write an algorithm, and then you develop it with a code. So this an engineer is supposed to do. The rest of all the computer already does. Right. So I hope that now you have understood how a new numerical relay is being developed. Okay. In the second part of video, we will see what are the important components of a numerical relay.